Okay, so I think we are ready to start. Again, thank you so much for being here in this new session of our microlearning program. Today we are talking about ventilation systems for refrigerated rooms in the event of a fire. And this kind of installation are compatible with the thermal insulation necessary for operation of the room. So we have with us today my colleague Oriol Radua. Oriol, you can connect your cam if you want, so everybody can see you. And he is fire safety and smoke control engineer here in the project department of SODECA. He's an specialized in this topic, so I'm sure you are going to enjoy and are going to find this useful, as always Oriol is with us. So thank you so much for being here, Oriol, and the floor is yours. Sorry, Oriol. Just a brief reminder of the operation of the housekeeping. We are having the session. Then when we finalize, we end. We are saying the presentation with all of us, and you have a question tag, a question panel. If you have any question, you can just write down the questions, and we will answer the question at the end of the presentation. Okay. Then, Oriol, your turn.
Okay, thank you very much, Carlos. Good morning, and thank you very much for attending this microlearning session. As my colleague said, well, I'm in the project department in SODECA. We design mechanical smoke control systems to address fire safety challenges. And today I'm going to talk about the ventilation in refrigerated rooms or cold rooms, depending the name that you want to say, in the event of a fire. And you will see our products, which are completely compatible with the thermal insulation required for the room's operation. Okay, let's start. So first of all, here we see the content, a smoke control system for refrigerated rooms, guide for smoke control systems for refrigerated rooms, calculation tool with our software QuickFan, and technical solutions for a smoke control room in refrigerated rooms. Well, first of all, just to put in context, historically, the smoke control system in refrigerated rooms has not been phased up due to the presence of a double roof, the roof of the refrigerated room and the roof of the general building, inside which many rooms are placed, with an area called plenum between the roof, between both roofs. Okay, we have the roof of the camera and the roof of the building, and this is a complex problem. The low temperatures are also another problem inside the room that could adversely affect the smoke buoyancy by limiting its extraction. Another problem is the physical difficulties to extract the smoke from a fire in the room to the outside of the building in comparison with a standard smoke control system for an industrial building. Another problem to face is the specific thermal insulation requirements for the components to be installed in the roof or walls of a refrigerated room in order to avoid energy losses. And finally, the last problem is the lack of technical guidelines for design of a smoke control system in refrigerated rooms. A few years ago, the fire safety cluster in the Barcelona area, which includes several working groups related to the fire protection engineering and in which SODECA actively participates, developed a guide for smoke control in refrigerated rooms. This guide has been recognized by the fire departments of Catalonia and Barcelona. This guide can be downloaded for free from the website shown in the screen, and it's available in Spanish. Sorry, not in English. I would also like to mention that a second version of this guide will be published soon, and it will include additional scenarios with different internal temperatures in the refrigerated rooms, as well as more configurations of storage layouts inside the rooms, along with the conclusions drawn from these new cases. So it's very interesting. When we have a building with cameras, we have different types of construction. Even though sometimes the building itself becomes a cold or freezer area, this is usually an area. There is usually an area between the roof and the refrigerated room and the roof of the building. So we have two roofs and an area between them that we call plenum. Some possible geometrical configurations are shown here below. For instance, in this case, we only have one building with one camera, but we can have one building with multiple cameras inside. We can have one camera that is the building itself, okay? And then we can have other configurations where the walls or roofs of the refrigerated rooms are fire compartment, let's say, elements. For instance, in this case, we have in red lines, we see here that the roof of the refrigerated room has this fire compartmentalization quality, and in this case, this wall is also it gives us fire compartmentalization. And we can have also different configurations where all the cameras are a fire compartment and all the walls and roofs gives this fire compartmentalization degree. The smoke control systems always have a goal. In this case, for smoke control in cameras, the goal is the access for firefighters. Okay, mainly the goal is access for firefighters. So the maximum temperature, if we want to reach this goal, the maximum temperature for the smoke layer has to be not more than 200 degrees. The minimum free of a smoke height, okay, this Y, okay, should be not less than 2.5 meters. Or if there is storage in the camera, the smoke layer should be 0.5 meters above the height of the storage. These are typical in all the smoke control standards based on buoyancy. You can see it in the BS 7346.4, in the British standard, in the European technical report, the TR 12101/5, for instance, or in the Spanish standard UENE 23585. Okay, typical, you can see it in this smoke control standards based on buoyancy using steady state fires. Okay. Regarding the room operation temperature, we can split it between below zero, okay, freezers, or above zero, just cooling or temperature control cameras. The low temperature could have a negative effect on the buoyancy of the smoke in case of fire, because in this kind of systems, we take advantage of the buoyancy of the smoke, but as the air that is entering to the plume is cold air, it gives, let's say, it gives less temperature to the smoke layer, so this buoyancy can be negatively affected. As we see here, the air introduced in the room to compensate the smoke evacuated will get cold due to the thermal inertia inside the room, and this low temperature of the air that will be introduced into the smoke plume can cause an increase of the air density. When the guide of the cluster of fire safety companies in Barcelona area was written, multiple CFD simulations were carried out in order to reach the following conclusions. The first conclusion is that the required time to achieve enough visibility for the firefighters is reduced when a mechanical smoke control system is used instead of natural system. Okay, different people of different companies, universities, etc., carried out CFD simulations, and as a conclusion, we saw that with mechanical extraction, the smoke was extracted quicker than with a natural system. And the second conclusion was that carrying out the design with a natural smoke control system do not provide enough ventilation. So it is recommended to use a mechanical ventilation system, especially for refrigerated rooms when there are sprinklers in the room. So now we'll see different solutions, okay, with mechanical extraction. First of all, there is the ducted extraction from the room to the outside, as we see here. And we can have, for instance, some kind of dampers on the roof of the refrigerated room connected to exhaust fans on the roof of the building. We can do it one by one, let's say one damper, one exhaust fan, or we can connect more than one damper to this exhaust fan. In this case, we would use this kind of damper. We will see the characteristics later on. And we can also use this other kind of system where we have this damper again, we call it fridge flap, exhaust fan here, and it can be connected to, let's say, natural smoke vent or just a duct with an elbow at its end. If the smoke control is also required for the plenum, okay, this area, like here, this area, it may be designed independently. Okay, we can have the smoke control system for the camera and the smoke control system for the plenum. But it can also be solved with only one system. Okay, if the fire breaks out inside the refrigerated room, a fridge flap, that is this damper, okay, installed here on the roof of the camera, will open, and the smoke control damper on the vertical duct will remain closed. Okay, if the fire is here, we open these fridge flaps, but we remain closed these smoke dampers here. But if the fire breaks out in the plenum, some smoke control dampers on the vertical ducts will open, and the fridge flap dampers will remain closed. Okay, if the fire is here, we open these smoke dampers, but these fridge flaps here remained closed. Then, in this example, we have 3 refrigerated rooms, and the smoke control system is solved using only 2 roof-mounted extract fans connected to all the rooms. Each room contains 2 fridge flaps, dampers, and the ducts running above the rooms are connected to 2 vertical shafts that lead to the extract fans. These vertical shafts are equipped with 2 smoke control dampers, so we can optimize the number of fans used with these systems that can give service to the fire inside the camera or in the plane. In this slide, we see 2 different examples with 2 types of fan. Okay, either of them can be used for this application, and smoke extraction from the refrigerated room to the outside can be carried out using point-to-point systems like this one, okay, 1 fridge flap, 1 fan, or using systems with a single fan like this one connected to multiple fridge flaps in the camera. Here we see another example with ducting from the refrigerated room to the exterior through the walls. And I would like to say that this configuration can also be used to introduce replacement air or makeup air into the refrigerated room at low levels. Okay, if we use it at upper levels, we can use it as extraction of smoke, but using it at low levels, we can use it as makeup air or replacement air into the cabin. Here we can see another solution that is without ducts. Okay, by providing fridge flap dampers in the roof of the refrigerated room and smoke extract fans in the roof of the building, we can solve the problem without ducts. This system allows to make the smoke control inside the freezer room or in the plenum area. But to use this system, the guide from the fire safety cluster in Barcelona area specifies that the space above the refrigerated room, plenum, okay, here, plenum, must be a non-occupied or only occasionally occupied zone, used exclusively for equipment inspection and maintenance. In this case, here we see 2 examples more. Okay, here with one fridge flap on the roof, or in the roof of the camera, and one extraction fan in the roof of the building. And in this case, we have another example in the right-hand side with one fridge flap on the roof of the camera and one wall fan in the wall of the building. Finally, we have the case of self-supporting refrigerated rooms, where the damper is located directly below the extract fan. Okay? In this case, we don't have another building. The camera is the building itself. So in this case, we have the fridge flap here, and just over the fridge flap, we have the extract fan. It is always required to provide fresh air or make-up air for the performance of the smoke control system. So this can be done by doors or natural vents at low levels of the camera, but it also can be done through fridge flap dampers here with a fan, okay, or inducted or directly coupled to the fridge flap. Here we have the fridge flap, and in this case we have a fan, and sometimes maybe we need a duct here, or just we can couple directly the fan with the fridge flap. There are different solutions depending on the every need of the building and the cameras inside the building. Regarding the calculation of the airflow rate to be extracted in case of fire, we would like to mention that our software, QuickFan software, that you can download for free in our website, includes a smoke extraction calculation tool based on the Spanish standard UNE 23585. We would also like to point out that the calculation methodology in this standard is essentially the same as the one found in the European Technical Report, the TR 12101 Part 5. In today's session, there is no time to go into detail about this tool. If you have any question when using it, please don't hesitate to contact us. And now I'm going to talk about our fridge flap damper. Okay, I'm going to talk about the general information, main parts, models, dimensions, pressure drops of these 2 models that we have, and accessories. So, as general information, motorized hatch approved as a smoke extractor accessory in accordance with standard EN 12101 Part 3. This is very important. Okay, we can use this fridge flap damper with one SODECA fan, extract fan, for instance F300 or F400, because this damper is approved as an accessory of an extraction fan. So you can perfectly use it when for this extraction, smoke extraction use. Okay, it is a flap with 90 millimeters Class B injected polyurethane insulation according to EN 13501. It has a thermal breach break profiles. Also, the thermal transmittance is less than 0.2 watts per square meter in Kelvin. The water timer, it has a water tightness seal with double air chamber, and it is a Class D in accordance with the EN 12207. It has a heating element of 40 watts per meter to prevent sealing joint from freezing. We only need to use it in under or below zero cameras. Okay, it is suitable for cold storage, let's say over 4 degrees, and freezer rooms between 4 and minus 28 degrees. It has 2 limit switches, both for open and close. Okay, both positions, open and close. It has a manual opening system in case of malfunction with this utility model. And it comes with a chain actuator with a reliability of more than 11,000 dual cycles. It means dual, it means open and close. Okay? And the opening time is 30 seconds. It can be installed vertically or horizontally. Okay, the finishing is an anti-corrosive in extruded aluminium, and the color is this RAL 9010, and it is supplied with trims to finish off the opening in the sandwich panel. Okay, because we have to create a hole in the sandwich panel, and then we supply these finishings for the hole. And is adaptable to any panel thickness with a maximum thick of 120. I would like to say something here. The trim pieces covers panels up to 120 millimeters by default, but on request, it can also be supplied for thicker panels. For instance, a typical 200 millimeters panel. So by default, the maximum is this 120, but on request, you can demand it for thicker panels. And here you can see the different elements of this fridge flap. This represents the panel of the camera. Okay, so here there is the hole. Okay, that we have to do in the panel of the camera. Then we have here the aluminum hinges that opens the flap, and very important, here you can see this water tightness seal, okay, this double camera seal. The flap, okay, the damper has this thermal breach brake in the flap, but also the profile that is, let's say, connected to the panel has also thermal breach brake profile. Okay, and here you can see the heating, the perimeter heating element. Okay, this is the L profile adaptable to the panel thickness, as I said, by default up to 120 millimeters, and this is the trim over, let's say,
Sorry, Oriol, we are not seeing now your cursor. I don't know why.
Okay,
now.
Sorry, I have it in the other. Yeah, sorry. Here is the heating element. Okay, the thermal breach brake of the profile connected to the panel, the thermal breach brake in the flap. Okay, this is the seal, the water tightness seal with double camera. Okay, the L profile to cover, let's say, the hole in the panel, and the trim to be installed over. Sorry, yeah, I see that. Yeah. The one that you are seeing is this one. Sorry. And these are the aluminum hinges. Okay. So here you can see the chain actuator. Okay, the limit switches. Okay, this one for the closed position and this one for the opening position, and this is the manual opening system. Okay, with this cable. Here you can see that we have two models, the fridge flap 100 and the fridge flap 150. Basically, there are two dimensions, okay, two sizes. And the actuator is a 150 power actuator with a maximum admissible current of 0.7 amperes. The voltage supply is 220 volts alter current. It comes with a protection class of IP20, and the time rating is 5% of 85%. Here you can see the dimensions. You can find it in our website. No problem with it. With all the different dimensions, I would like just to say that the hole is A by B, okay, and for the fridge flap 100 is 850 by 850, and for the fridge flap 150 is 1360 by 1360. Okay. And here you can see the pressure drop for the two different models, depending on the airflow that is through is blowing or is passing through the number. Okay, we have tested in the laboratory, so we know the aerodynamic area and the C sub V coefficient, so we know perfectly well what is the pressure drop depending on the airflow passing through the damper. Okay. Finally, here we can see the compatibilities. Okay, with the fridge flap 100 can go with fans from diameter 63 to diameter 100. Okay. And the fridge flap 150 can go with fans of diameter 125. And you can see different models of our fans: the THT hatch, the HTMF, the THT roof, the THT wall, the simple THT, or the THT long case. Okay. And we have these two accessories that can couple with the fridge flap. This is the MT, just in case that you want to connect the fridge flap to a circular duct. Okay, and we also have this B-tube that if you can connect both. First, this MT to the fridge flap, and then the B-tube to the MT, and then you easily can connect the circular duct to this B-tube. Okay. And that's all for my part. And now I think if there are questions, we can deal with them.
Thank you, Oriol. You can take a sip of water if you want. I am going to share the presentation with the public, and meanwhile, they can write down all the question they have. Okay. So I'm now sharing the presentation with you, and in the meanwhile, you can write your question for Oriol. I think everything should be clear because you did a fantastic presentation as always, but I'm sure we can have any questions or doubts. So I am now sharing the presentation. I think you all can now see it in the tag of documents, and you can download it. And let's see if we have any questions, Oriol.
Okay.
Not at the moment, So probably our public is a little bit shy, but anyway, if you don't, if you can't think in a proper question for today, you always can write Oriol or me, and we can answer the question later. But it seems like we have one, Oriol.
Okay.
The question is, wall flap is certificate for natural fresh air supply?
Not at the moment. For supply, yes. Not
supply.
Supply, yeah. For supply, there are two situations. Okay. Basically, as long as it goes with an extraction fan that is certified as an accessory of an extraction fan, a certified fan, so there is no problem. Then, if we are, let's say, doing this air replacement at low levels, and in the calculations, this is under the smoke layer, we can use them. Okay, we can use them, no problem. If we are, let's say, in a project that is, let's say, for instance, a performance-based design, and this smoke layer is not well defined, but maybe is admissible or acceptable that some smoke or some people evacuating, for instance, can be in contact with the smoke, but this smoke has not the temperature, high temperature, or it has not high, let's say, toxicity. And we have a smoke, but the tenability criteria is acceptable for people. In this case, as we have a smoke at low levels, we should use certified products by the EN 12101 Part 2. At the moment, the fridge flap is not certified as a natural smoke band by the EN 12101 Part 2. So it can only be used if the calculation says that it will not be in contact with smoke. Okay, if the smoke layer is above this height, we can use it, but if not, then we cannot use it. Unless it is installed with a THT fan, for instance. No, THT fan is our certified extraction fan, F300 or F400, depending on the requirements. But then in this case, then we can use even though it's in contact with smoke.
Okay, thank you, Oriol. We have another question. What is the minimum size of cold room that we have to evacuate the smoke?
Well, it depends on national requirements, for sure. Here in I know what are the requirements in Spain, but I'm not sure if it is something interesting for people in other countries. In Spain, it depends it's called the level of risk. Okay, we have 9 levels of risk depending on the let's say on the kind of combustible and the amount of combustible inside a production plant or a warehouse. And depending on this, we have different levels. And when we have these 9 levels are divided in 1, 2, 3, 4, 5, 6, and 7, 8, 9. And this is low risk, medium risk, high risk. In this case, when we have dimensions depending on production or warehouse, and if it's middle risk or high risk, then we have to apply the, let's say, the Spanish standard, this UNE 23585. When we have to use this, if you want, I can say what the regulation says.
You can give us an example for the Spanish regulation.
For instance,
for other countries, they can consult us.
Yeah. For instance, in Spain, if we are talking about warehouses for medium risk, we have to use these smoke control systems complying with the Spanish standard for 1,000 or more square meters. In high risk, 800 or more. And in this case, we have to comply with the standard. But for, let's say, smaller rooms, we have to only guarantee air changes per hour. And depending on the case, is 6, 9, or 12 air changes per hour. But then there are, let's say, less stringent requirements. The standard has stringent requirements. It's not only the amount of air that you have to extract, but also there are other requirements. Okay, in the case of smaller rooms, always the Spanish regulation says that for refrigerated rooms of less than 100 square meters, you don't need to do anything. Okay, but from 100 and bigger up to this 800 or 1,000, you can just use, let's say, ventilation ratios. And depending on if it's over the ground floor or underground floor, and if it is production or warehouse, you have to use 6, 9, or 12. Okay, And when you reach this 800 for high risk or 1000 for medium risk, then you have to comply with all the Spanish standard. And then it's not a ventilation ratio. You need to do the calculations as per the Spanish standard that is based on the Thomas equation. And it's kind of, and they use steady state fires, and we use the Thomas equation.
Okay, thank you all. So people are getting less shy, so we have more questions.
Okay.
How we control the flaps, opening and closing?
Okay, we need a control panel for sure. We at SODECA, we have our control panels for smoke control systems. We call them box smoke control panels. And for sure, we need to connect fans and dampers to the main control panel. And depending on the logic, we can manage them. Okay, because in a smoke control system, depending on if there are sprinklers or not, and the kind of a sprinkler is different if we have ESFR sprinklers or just control sprinkler. Maybe the kind of activation for the smoke control system is different. Sometimes it has to be only manual operation. Other cases, maybe you can have automatic operation, but with the delay to the sprinklers device activation, or in other cases when evacuation is the main goal, the activation of the system should be automatic. So in our control panels, well, you can decide what kind of activation you need depending on the requirements of the system.
Mm-hmm. Thank you. Another question. What is the airflow for the compensation, for the makeup air? I understand.
Oh, makeup air. Well, of course, depending on if we are doing it naturally or mechanically. If you are doing it mechanically, our advice is to go to 80% of the extraction flow rate. Okay, we don't want the camera in overpressure. We want them in the pressure, but it cannot be such a great pressure. So because it
cannot be in vacuum. Cannot be in vacuum.
Exactly, because it could, let's say, reach to or go to structural problems. So with this 80%, it works very well.
Okay, another question. Does it make sense to just do a smoke control in the area above the freeze room?
Not in my opinion. Not in my opinion, because if you have a fire inside the refrigerated room or the cold room, in the end you have to extract the smoke. As I said, it's not the same. For instance, a refrigerated room or a temperature control room, let's say 6 degrees, with people working inside. Imagine a lot of people working inside. Then the goal of the system should be evacuation. So then you need a smoke control system with this goal of evacuation. But now go to the opposite. A cold room with maybe 2-3 people. This is for sure the goal of evacuation is not the big goal for the systems here, okay, because evacuation is guaranteed without any kind of system. But then if you want firefighters to go into the cold room and find the fire and tackle the fire quickly, you will need a smoke extraction system, let's say, in order to provide this way free from smoke for firefighters to reach the smoke. And also, when the fire has been extinguished, we need to clear the camera or the cold room from this smoke inside the. Then it's something related to the wishes or let's say of the customer. If they want to operate this, the building in less time, they need this smoke extraction system so they can again let's say work in minutes, maybe maximum 1 hour. If they have a smoke there for 24-48 hours, well, they cannot let's say, following with activity. So,
okay, thank you. And I think the final one, what is the maximum allowed speed in meter per second for the evacuated smoke through the duct connecting the extractor and the hatch?
in the duct. There is not. This is not something that we can find in the standard or in regulations. As a recommendation, we recommend not to overpass 10 meters per second in this duct. Okay, and then the maximum airflow that one point can extract. There are equations that can give us this value in our software. The quick fan in the smoke control systems tool, when you are carrying out calculations, at the end of the list of parameters, you can see minimum smoke extraction points, because there is something called the plug holing. Okay, that is let's say that every extraction point has a maximum capacity depending on the depth of the smoke layer. If the depth of the smoke layer, let's say, is a thin layer, at some point, this extraction point is sucking air from the free from the smoke part instead of sucking smoke. Okay, so depending on the size and the shape of this smoke extraction point and the depth of the smoke layer, there is a maximum airflow every smoke extraction point can, let's say, accept.
Okay, Oriol, thank you so much for your answers. I think we don't have more questions, so let's finish for today. Thank you so much for being here. And we are coming back to the microlearning sessions after the summer here in Spain. So thank you so much for being here. Thank you, Oriol, for your presentation, and see you soon.
Thank you very much.